Question 18. Here is a prism ABCD SPQR. The base ABCD of the prism is a square of side 14 centimeters. T is the point on BC such that BTTC is 4 to 3. The cross section of the prism is in the shape of a trapezium of area 147 centimeter squares. CR is equal to 12. Find the size of the angle between the line ST and the base ABCD. Give your answer correct to 1 decimal place. So firstly, let's join up D and T. So here I have a right angle triangle, this SDT. And within this triangle, I want to find the angle between ST and the base, which is this angle here. So we've got the triangle SDT. It's a right angle triangle, and it is this value of theta that I want to find. So ideally, I need to find some lengths here. Now, looking at this, none of these lengths are labelled. So let's use the information we've got to see what extra information we can put on our diagram. Let's start with T is the point such that BTTC is 4 to 3. So if we split the line B to C into 4 plus 3, 7 parts, we know the length of B to C to be 14 centimeters, as this is a square. 14 divided by 7 is equal to 2, so each part is worth 2. So splitting in the ratio B to T to C being 4 to 3, B to T is 4 times 2, T to C is 3 times 2, which means I've got 8 centimeters to 6 centimeters, which I can now label on my diagram. Now let's look at the second piece of information. The cross-section of the prism is in the shape of a trapezium of area 147 centimeter squares. So here's my trapezium on the face of this shape, PQAB, and I know the area to be 147. Now I'd be quite interested in finding this height here, PA, because that will be the same as the height of my SDT triangle. It will be the distance between S and D. Now I know the base to be 14, and I know B to Q to be the same as C to R, and so that's 12. The area of a trapezium is the area is equal to half of the top and bottom, so in this case x plus 12, multiplied by the perpendicular height, which here is 14. To divide both sides here, half times 14 is 7, so dividing both sides by 7, 21 is equal to x plus 12. Subtracting 12 from both sides gives us this x value. Knowing this value here, P to A is 9, is knowing that S to D is 9, so I can label that now on my triangle. Now also, if I look back at my diagram, I've got this triangle CDT, which is a right angle triangle, and I need the distance here between D and T. So I'm labeling that side H because I know C to T is 6 and I know C to D is 14. I can use my lovely Pythagoras' theorem to say that H squared is equal to 6 squared plus 14 squared. I can evaluate that on a calculator. H squared is 232, and so H is 2 root 58, which I can now put as the length dt on this right angle triangle. I now have a right angle triangle where I know 2 of the sides and I just want to find the angle. So I have opposite to the angle and adjacent to the angle, which means I'm looking at TOA. And so tan theta is equal to the opposite, 9 divided by the adjacent, which is 2 root 58. And so my theta is tan to the minus 1 of 9 over 2 root 58. Again, evaluating that on my calculator, I get theta to be 30.57 and so on, but my answer needs to be correct to 1 decimal place. Since we have a 7 to the right of this 5, it will round up to give me a final answer of 30.6 degrees.